All the objects can produce the same effect as produced by the plane mirror. A ray of light falling on a body having a shiny, polished and smooth surface alone is bounced back. This bouncing back of the light as they fall on the smooth, shiny and polished surface is called reflection. So reflections involves two rays, one is incident ray and another one is reflected ray. The incident ray is the light ray in a medium falling on the shiny surface of a reflecting body. So after falling on the surface, this ray returns into the same medium. This ray is called the reflected ray. And an imaginary line perpendicular to the reflected surface at the point of incidence of the light ray is called the normal. Actually, this normal divides the angle between the incident ray and the reflected ray into two equal angles. The relation between the incident ray, the reflected ray and the normal is given as the law of reflection. So the law of reflections are as follows. One is the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Next, the angle of incidence and the angle of reflections are always equal. The incident ray, normal and the reflected ray are given in the picture. Types of reflection. You have learned that not all bodies can reflect light rays. The amount of reflection depends on the nature of the reflecting surface of a body. Based on the nature of the surface, reflection can be classified into two types. They are regular reflection and irregular reflection. Regular reflection. When a beam of light, that means a collection of parallel rays, falls on a smooth surface, it gets reflected. After reflection, the reflected rays will be parallel to each other. So, here the angle of incidence and the angle of reflection of each ray will be equal. Hence, the law of reflection is obeyed in this case and thus a clear image is formed. This reflection is called regular reflection or specular reflection. Example, reflection of light by a plane mirror and reflection of light from the surface of still water. The image of still water you can see in the picture. Irregular reflection. In the case of a body having a rough or irregular surface, each region of the surface is inclined at different angles. When light falls on such a surface, the light rays are reflected at different angles, isn't it? So in this case, the angle of incidence and the angle of reflection of each rays are not equal. Hence, the law of reflection is not obeyed in this case, and thus the image is not clear. Such a reflection is called irregular reflection or diffused reflection. Example, the reflection of light from a wall and the reflection of light from the surface of wavy water. Multiple reflections. Let's do an activity to know the multiple reflection. It's simple. Take two plane mirror and keep them perpendicular to each other. Place an object in between them as shown in the picture. Here in the picture, a bottle is placed in between the two perpendicular plane mirrors. So here you can see the images of the object. So how many images do you see in the mirror? You can see 3 images. How is it possible to have 3 images with 2 mirrors? In this activity, you observe that for a body kept in between 2 plane mirrors, which were inclined to each other, you can see many images. This is because the image formed by one mirror acts as an object for the other mirror. The image formed by the first mirror acts as an object for the second mirror, and the image formed by the second mirror acts as an object for the first mirror. Thus, we have 3 images of a single body. This is known as multiple reflection. This type of reflection can be seen in showrooms and saloons. The number of images formed depends on the angle of inclination of the mirror. If the angle between the two mirrors is the factor of 360 degree, then the total number of reflections is finite. If theta is the angle of inclination of the plane mirrors, the number of images formed is given by the formula 360 degree divided by theta minus 1. As you decrease this angle, the number of images formed increases. When they are parallel to each other, the number of images formed becomes infinite. The infinite images you can see in the picture. Kaleidoscope. It is a device which functions on the principle of multiple reflection of light to produce numerous patterns of images. It has two or more mirrors inclined with each other. It can be designed from inexpensive materials and the colorful image patterns formed by this will be pleasing to you. So this instrument is used as a toy for children. Periscope. It is an instrument used for viewing bodies or ships which are over and around another body or a submarine. It is based on the principle of the law of reflection of light. It consists of a long outer case, and inside this case mirrors or prisms are kept at each end, inclined at an angle of 45 degrees. Light coming from the distant body falls on the mirror at the top end of the periscope and gets reflected vertically downward. This light is reflected again by the second mirror kept at the bottom, so as to travel horizontally and reach the eye of the observer. In some complex periscopes, optic fiber is used instead of mirror for obtaining higher resolution. The distance between the mirror also varies depending on the purpose of using the periscope. Uses of periscope. It is used in welfare and navigation of the submarine. In military, it is used for pointing and firing guns from a bunker. Photographs of important places can be taken through periscope without trespassing restricted military regions. Fiber optic periscopes are used by doctors as endoscopes to view internal organs of the body. Refraction of light. We know that when a light ray falls on a polished surface placed in air, it is reflected into the air itself. When it falls on a transparent material, it is not reflected completely, but a part of it is reflected and a part of it is absorbed, and most of the light passes through it. Through air, light travels with the speed of 3 into 10 to the power of 8 meter per second. But it cannot travel with the same speed in water or glass because optically denser mediums such as water and glass offer some resistance to the light rays. So light rays traveling from a rarer medium like air into a denser medium like glass or water are deviated from their straight line path. This bending of light about the normal at the point of incidence as it passes from one transparent medium to another is called refraction of light. When a light ray travels from the rarer medium into the denser medium, it bends towards the normal, and when it travels from the denser medium into the rarer medium, it bends away from the normal. You can observe this phenomenon with the help of an activity. Take a glass beaker, fill it with water, and place a pencil in it. Now look at the pencil through the beaker. Does it appear straight? No, it will appear to be bent at the surface of the water. Why? In this activity, the light rays actually travel from the water, that means a denser medium, into the air, that means a rarer medium. As you saw earlier, when a light ray travels from a denser medium into a rarer medium, it is deviated from a straight line path. So the pencil appears to be bent when you see it through the glass of water. Refractive index. Refraction of light in a medium depends on the speed of light in that medium. When the speed of light in a medium is more, the bending is less. When the speed of light is less, the bending is more. So, the amount of refraction of light in medium is denoted by a term known as refractive index of the medium, which is the ratio of the speed of light in air to the speed of light in that particular medium. It is also known as absolute refractive index, and it is denoted by the Greek letter mu. So mu is equals to speed of light in air by speed of light in the medium. So mu is equals to C by V. So refractive index is a ratio of two similar quantities, that is speed, and so it has no unit. Since the speed of light in any medium is less than its speed in air, refractive index of any transparent medium is always greater than 1. Refractive indices of some common substances are given in the table. Let's see the table. The refractive index of air is 1.0 as we already know, and for water it is 1.33, for ether it is 1.36, for kerosene it is 1.41, and for glass it is 1.5, and for quartz it is 1.56, for diamond it is 2.41. So in general, the refractive index of one medium with respect to another medium is given by the ratio of their absolute refractive indices. So mu is equals to, that means 1 mu 2 means the refractive index of first medium and second medium. So mu is equals to absolute refractive index of the second medium by absolute refractive index of the first medium. So mu is equals to C by V2. That means the refractive index of the second medium is C by V2. Then the refractive index of the first medium is C by V1. Otherwise you can write mu is equals to V1 by V2 because C and C is going to be cancelled. Next, thus the refractive index of one medium with respect to another medium is also given by the ratio of the speed of light in first medium towards speed in the second medium. Let's see some problems related to refractive index. The first one, speed of light in air is 3 into 10 to the power of 8 meter per second and the speed of light in a medium is 2 into 10 to the power of 8 meter per second. Find the refractive index of the medium with respect to the air. So what's the solution? What's the formula to the refractive index? It is speed of light in air divided by speed of light in the medium. So mu is equals to C by V. So 3 into 10 to the power of 8 by 2 into 10 to the power of 8. So what we will get? 1.5. So what is the refractive index of the medium? It is 1.5. The next problem, the refractive index of water is 4 by 3 and the refractive index of glass is 3 by 2. Find the refractive index of glass with respect to the refractive index of water. So here mu is equals to refractive index of glass by refractive index of water. So 3 by 2 by 4 by 3. So 3 by 2 into 3 by 4 is equals to 9 by 8. That is equals to 1.125. So what is the